Yes, so I think I gave this presentation at Gforth Tagung, some presentation like it at Gforth Tagung. So a while ago I found that the Gforth decompiler is lacking. It tried to decompile using the threaded code plus the native code and get back from there. And the results were not so great. And so I thought, shall I do? And there were some interesting ideas about getting a complicated system for getting better results from the native code. But eventually I decided to just record what the primitives are that I compile and work with that. And this is what you see. So basically, if you have some word like this, you can then say C, foo, and you get some decompiled thing, and you see here it's decompiled into decimal 1 with explicit base prefix. And so that's the C is the decompiler that tries to be as close to the source code as possible. Then the next level is simple C, which shows you the primitives. So you see that we have here drop and lit primitive, and the lit has an immediate argument 1. And here we have a semis literal, which is comes from the semicolon. And what you also see here, we already see the stack states. So drop goes from 1 to 0 stack items in registers, and lit goes from 0 to 1. And of course, it all at every point you have to continue where you left off at the last primitive. And at the start of a basic block, we are in state 1. At the end of a basic block, we are also in state 1. Right. So the next level is the native code. So we have here C code. And we see that the drop decompiles to nothing. So it compiles to nothing, and therefore the decompiler also doesn't show any code. And that's one of the advantages. I couldn't easily do that from going back to from native code. The lit compiles to this move. And yeah, the semis compiles to this sequence. Right. So and I've already shown you the stack states. So what else can I show you? One thing is that Gforth also has static super instructions. For example, this is one. So when we decompile it, it actually shows up pretty normally. But when we do it with C code, it actually shows here as first primitive not dupe, but dupe to R. And this means that this is a static super instruction. And we see here the 2R. So basically the first threaded code slot is taken by the dupe 2R. And we still have a threaded code slot left for the 2R, and that's why you see that here. But this threaded code slot is not used. And this is the native code for the dupe 2R. And again, native code for the semis. One other thing is there are some primitives that are not that the native code cannot be copied. These are typically things that call C functions. So if we have blah open file and we do a C code of blah, then we see the open file. Actually, there is no native code for it. And how do we know that this is not just something like the drop that compiles to nothing? We see that by it not having a stack state transition, so which is a very maybe I should be having a more clearer indication that that this is referring to a to native code that's that's not being copied, but yeah, that's.
Is just write prim there or something for primitive?
Or non-relocatable. Yeah, maybe like that. But for now, it's like this. If anybody of you would like it to be more explicit about these things, yeah, write to me and I'll see what can be done. So that's mainly the features that we see. And any questions? So it is a little bit shorter than 20 minutes.
Where do we get the latest snapshot from? Is it? Oh, where do we get the latest snapshot? Is it on GitHub or whereabouts?
The latest snapshot of Gforth, actually, you do. So you had the very latest code is on Savannah. And from Savannah, it goes to GitHub in some way, but it first is on Savannah. I'm not sure when it's updated on GitHub. When you go to, oh yeah, you got this. When you go to, I'm not sure if you see this. So it's our website.
Our website is gforth.org.
Yeah, well, the website of my place of work, and the snapshots are there. Mm-hmm. And yeah, well, let's see what.
What's the web address of this?
Yeah, I'll just.
I think it's linked on gforth.org.
Oh yeah, let's see.
And if not, we will link it in a moment for you. There should be something, scroll down a bit, download, install.
So yeah, bleeding edge snapshot, and yeah, there you are. So gforth.org is the one that you have to
worry about.
Yeah, that you have to remember.
So is that the web?
Yes, there you go.
Oh, yes. Yeah. So this is 0.7.3?
No, that's the latest release. And below it is the bleeding edge snapshot.
Oh.
I would like to ask, maybe you've said it before, but I was busy doing the OBS. Why is there a $sign in front of the force words, but not of the assembly words? Is it for easy grabbing or something?
This is basically this comes from the decompiler.
Yes.
And this comes from the disassembler. So depending on how the disassembler was written, it does it like this or like that.
Okay. No, it's interesting because it actually gives you a feeling of, this is the high level, this is the low level. I think it's cool.
Yeah, it's in some sense it helps you with the difference. But of course, you can also switch to a different disassembler. So if you want to use the one from GDB,
yeah,
you can then say C code. I have to do something about it. is this code.
Hold on, I'll show the chat as well. There you are.
And if you get to this code blah, you get now the decompiler output.
It looks even different again.
Yeah.
Mhm.
Yeah.
Okay.